So, today we're going to tackle a huge question. How does a simple app, something built on just one computer, grow to support millions and millions of users? We're going to break down this idea of scaling. And believe me, it all starts in a very, very simple place.
I mean, you've got to wonder, right? You open up an app and it just works, instantly, even when thousands, maybe millions of other people are hitting it at the exact same time. How is that even possible? Well, it all comes down to this one critical concept, scalability. And the journey to get there, it starts smaller than you think.
All right, let's start at square one. Picture this. A developer writes a really clever piece of code on their personal computer. It takes in some information, does something smart, and spits out a useful result. People love it. In fact, they love it so much they're willing to pay for it. Okay, so obviously the developer can't just hand out their laptop to everyone. So what do? They expose that code through something called an API. Just think of an API as a digital front door. It lets other apps knock, make a request, and get a response back. And to make sure that front door is always open 24/7, they host it on a cloud server, basically a super powerful, super reliable computer sitting in a massive data center somewhere.
So now the service is live, it's reliable, and people are absolutely loving it. It's a huge success. But with that success comes this fantastic, but very, very real problem.
The requests start pouring in. I mean, more and more users are hitting your service all at once. And pretty soon, that one single cloud server, well, it just can't keep up. It gets totally overwhelmed. Your app slows to a crawl, maybe it even crashes. So what on earth do you do now?
The answer is scalability. This is the key. It's all about having a system that can handle a growing amount of work simply by adding more resources. You're essentially throwing more power at the problem to handle the demand. But how you add those resources, now that is the big decision.
And this brings us to a huge fork in the road. When you need more power, you really have two fundamental choices. Are you going to scale up, or are you going to scale out?
So on one hand, you have vertical scaling, which we call scaling up. Think of it like swapping your car's engine for a massive supercharged V8. You stick with just one machine, but you make it an absolute beast. Then, on the other hand, you've got horizontal scaling, or scaling out. This is like saying, forget a bigger engine, let's just buy a bunch more cars and build a whole fleet. You keep your original machine and just add more and more of them to share the workload. So, which is it? One giant, powerful machine, or a whole fleet of smaller ones? Well, each path has some serious pros and cons. Let's really dig into the trade-offs. This table lays it all out, so let's walk through it. First up, resilience. With vertical scaling, you have one giant machine. If that machine fails, your entire service is offline. That's a single point of failure. But with horizontal scaling, if one machine goes down, no big deal. The others just pick up the slack. Next, communication. Inside one big computer, different parts can talk to each other incredibly fast. But when you have a bunch of different machines, they have to talk over a network, which is way slower. Then there's data consistency. This one's tricky. It's pretty easy to keep your data consistent when it's all in one place. But when it's spread out across dozens or hundreds of machines, it gets really tough. Imagine trying to make sure every bank teller in 1,000 different branches has the exact same up-to-the-second account balance for every customer. That's the puzzle you're trying to solve. And finally, you have complexity and limits. Scaling up is simple. You just buy a bigger box, but you'll eventually hit a wall. You literally can't buy an infinitely powerful computer. Scaling out is more complex to set up, but in theory, you can just keep adding new machines forever. So as you can see, there's no single perfect answer here.
Okay, so if neither option is perfect on its own, what do the big apps that we use every single day actually do? How do they solve this puzzle?
And this quote right here just nails the real-world strategy. See, it's not an either-or choice. It's a phased approach. You almost always start by scaling vertically because it's just simpler. You make your first server as beefy as you can. But once you hit that ceiling, once you've got a ton of users who trust you, you have to make the switch and start scaling horizontally to handle that massive global scale.
So the real-world answer is a hybrid. It's the best of both worlds. You scale out by adding lots and lots of machines, which gives you that incredible resilience and almost limitless growth we talked about, but you also scale up by making each of those individual machines as powerful as you possibly can. This hybrid approach gives you the reliability of a fleet, but with the raw speed and power of a bunch of strong individual units. It's the brilliant compromise that pretty much powers the entire modern internet.
So, the next time you have that spark, that brilliant idea for an app or a service, the question isn't just, will it work? The real question, the one that separates a small project from a global phenomenon, is how will it work when millions of people are using it? Because planning for that growth, choosing your path to scale, that's everything.